Hello, all. Welcome to Roadways. This channel was started with the motive to understand the automotive concepts and also physics, which is also used in the mechanical world. So, into deeper dive sessions or like surface level, which is also relevant to the customers who are buying the product and using it, so that we understand the concept before buying, choosing the right product. As a start, the peak one of this series was a previous video on the tire size, on what it means, and how a customer can go and ask for the right size of rim, or how we can select based on its usage, or if it's an ICE or a BEV, the electrical and the engine counterparts of the automotive powertrain. So how we can choose the tires which fits best for this use case. Since it's been quite a bit of time between these two videos, I would like to propose that you will have to verify the peak one, which was on the tire size, and then come to peak two now, where we would like to deep dive into tire types, components, and the certifications that are used in the tires. Tire types will basically speak about the various types of tires that are available in the market, how the tire industry is segmented, and also components will give a perspective for users, or for the general audience who think tire is a rubber, molded rubber, which says there are multiple layerings into the tire, which does its specific roles and responsibilities. And also regarding certifications, there are also homologation process that a tire industry has to go through, and they get a label before launching the tire into the market. So how can users use the same label as a selection criteria before buying the tire? That is also being discussed in this YouTube channel. Regarding this YouTube video, what I have planned is like a surface level checks on all these aspects for an regular user or a customer to go into the tire shop or a tire mechanic, or before buying a car, going into the delivery showroom and to choose a tire. But also, I have provided Udemy courses on the in-depth of the tires, which will be more interesting for engineers or academic professionals to take a look on of all these topics in a depth perspective. So, without much delay, I will start with the types of tires overview. We can segment tires into various segments, like based on sales, based on techniques of building or design, or based on usage. So this can be classified widely, but what I have provided here is just the start of what the tires are. So based on carcass material, so I will explain about this carcass word in a few further slides, but now I would like to say, based on the carcass material, the tire is divided into certain types based on what material is used inside this carcass. And based on the construction, this is very important, where we see the radial and bias type tires. So radial tires are mostly used, and bias is used only for special purposes like truck tires or the bus tires. Now, mostly our cars are running with radial tires, which is more advantages for ride comfort and also mileage, fuel efficiency in those aspects. So for I we have covered a bit of this in our previous video also, so you can check out the peak one of tire size there. And inside this, there are also two types. One is tube and tubeless. Mostly, it is tubeless now. We don't have tube tires. We have tube type tires in certain cases, like again the truck, bus, bias tires. So truck and bus tires. So based on the application, we have light truck tires. Like light truck is like Tata Ace aspect, and also like a truck or a bus, passenger cars, two-wheeler, three-wheelers, agriculture, tires, and so on. So there are also based on tread pattern design. So tread pattern is nothing but the outside design of the tires, what you see. So basically, based on this, there is a rib. This is called a rib structure on the tire. So there is a rib tire. Lug tire is for mining purpose, where you have more square blocks of ribs in the tires itself, so it will be arranged in a certain parameter. Also, the off-roading two-wheelers, Hero Expulse, Impulse, those kind of vehicles use these kind of lug structure to plow into the sand and provide you more grip during uh, the race. And also, there is a similar pattern for in tractors and other applications to combine the advantages of both of these. And yes, now we come into another aspect of classification, like this is very important and widely spoken in the industry. That is asymmetric part and also symmetric types of tires. So asymmetric tires are like the tread pattern. If you take a mirror line into the center of the tire, cross section, you see this side of the tire is having a different tread pattern, tread design, and this side of the tire is having a different tread design. That's what asymmetric means. We also have non-directional and directional types, which can be fitted in only one direction. Like for example, this tire is more direction in this way. So it can be fitted in this way to increase the aquaplaning efficiency and also wet handling. So this is like more non-directional, which can be fitted either way, and it provides the same features compared to this. So it's like an hybrid approach we have here, and we also have a symmetric pattern where if you see the take the cross section and mirror it, it will be same on both the sides. The tread design will be same on both the sides, and then here also we have a directional. Here you can see it more clearly that the channels or the grooves, the lateral grooves, as we call, are in more in one direction of the rolling direction. And also, more importantly, we have the summer tires, we have the all-season tires, we have the winter tires, and all-terrain tires. So, summer tires, as in the name, are very efficient in summer conditions where there are dry roads, and all-season tires are equipped with good water irrigation channels, as you can see, more prolonged lateral grooves here. So, winter tires are for icy roads, which also have very rugged kind of a tread pattern design. So these are for ice conditions. And also not only in the tread pattern it changes, it also changes based on the rubber compounding. So this we will cover in later parts of the video, but there is something very important going on with this. This is called rubber compounding. So where you have the tread material as a hard or a soft compound that can be used to tackle these changes. And all terrain tires or like off-road vehicles, they have a lug. See, these are the lugs that are very prominent, and it can be used to plow the surface of the mud in which the vehicle is traveling. So to move further, we have the components and their function. So in this video, as I said, like I will not go in depth. For that, I have a separate Udemy course. So this function part will be covered there into detail, as I have already prepared here in the future. But now I will just go into the various tread components which are available in the tire. So as you can see here, we have to start with the outer layer, we have something called as a tread, also called as tread cap, like a cap. We have the tire is wearing a cap. So this tread layer is what determines the tire road contact. So it's very important to be sure of the design or the pattern which we saw in previous slide, and also the material that we use for this rubber. So mostly these are like, well, as I said, like it will be a hard compound or a soft compound, and it all depends on what rolling resistance we want, like a fuel efficiency, which we will speak about in the homologation topic. So and then we have the base cushioning layer from the tread. So we don't want the belts to be directly underneath the tread cap, which will take the load. So load will travel from here. This is from the road. The load is coming, and then this should be like smoothly transferred to the belt. So in between we have what is called as the base, but this base can be used for various purposes like NVH tuning. So based on the size of Based on the size of this base material, the width of the base material, we can tweak the how much noise is going to come inside as a structure bond. And then we have belt layers. Usually there are two belts in a car tire. So one is like a working belt and another is like a transition belt. So this working belt takes the load and then it transmits this load to the transition belt, from where this load will go to the carcass. So carcass is what like we saw in the first slide. Based on the carcass, this carcass is a very important layer of the tire, also known as the body ply. So body usually all these layers are a sandwich of a rubber. Okay, say this is the hatched section is a rubber layer, and this dotted lines that are go inside are called as reinforcements. So this is like a rubber, and this is like a reinforcement. So you can think it of like a composite where there are reinforcements running through a rubber. So what we see here is that body ply. So this reinforcement materials is what we saw as nylons, polyesters, or many other fabrics that can be used, or it can be metal, steel cords running through this rubber layers. So that is what are mostly used for ride comfort purposes, and also they don't change the contact shape much, so they are preferred for more efficiency. And we have the next layer, which is the sidewall, which is like flexing a lot. So we have the sidewall layer. Based on the flexing of the sidewall layer, we can vary the stiffness of the tire, and also further parameters are affected due to this. So basically, as from customer standpoint, the sidewall has engravings on the outside where we can see the tire size, tire name, and the speed index and load index of the tire, and when the tire was done. Usually it is called as a dot code. For example, it can be like 2025, which means it is 25 is the year of manufacture and we have 20 as a week of manufacture. So from this, the user can know at what point of the year the tire was manufactured. So these kind of details are engraved into the sidewall. I hope these contents have been elaborately discussed in our previous video, the peak one of tire size and sidewall engravings. And the next layer we have is the inner liner. The inner liner is very important for air retention. The main job of the inner liner is to retain the air. And the next layer we have is called as the triangle apex. That's what we call it. It is called as, sorry, apex. So this apex generally is like a load transfer stiffness region. So where we said like initially the load will come from the top and it will go through all these layers and it will come to the bead, and from the bead it is transferred to the rim cushion. So bead is a metal layer which takes the load and gives it to the rim cushion. So this is where the rim will sit. So rim is metal and we have a metal bead ring. So to smoothly transfer the forces, we need a hard rubber, which is basically this apex. So apex is nothing but a hard, stiff rubber which we have between the bead and the body ply, so that the load is getting evenly transferred. So now we know there are a lot of layers and they have unique responsibilities in the tire. So I have covered this in depth and how this each layers interact with each other and how we can prevent the failure, what are the other hidden layers or the layers which are of importance that is added to the tire in the Udemy course video. So for now, I will go on to the labeling of tires, which is also an aspect we have seen here. So now I will comment upon the tire label. From user standpoint, as I said, this is a surface level video, and the Udemy will speak about more in depth of what it really matters, what the labeling really says. For an regular user, you head out to a store. For example, you want to buy a refrigerator. You also have something called as a star rating. So most people will know like how the star rating will affect the energy efficiency. Even when you buy an air conditioner, you see the label of for how much star rating it is. So if it is more star rated, then obviously it is going to cost you more, but it is also going to save you more electricity bills in the long run. So that's what is the industry norms. So similarly for tires, we have what is called as Euro labeling, as you see here. So this labeling is based on certain testings according to certain standards we have, which will be covered in depth, as I said in Udemy course. But here, what we will see is how an user can interpret in the surface level when he chooses a tire. For example, you go to the tire store and you wanted to change your tire. Your store manager or a representative will show you a tire which has this kind of labeling fitted onto the tire. First, you will see for the manufacturing date, which is normally written on the side wall as dot code, as I explained previously. So you have a four-digit number where you have the week number, for example, 21 and 25, what we saw. So week number and the year number. Ideally, we prefer it to be a 5 year, lesser than 5 year old tire. Otherwise, it's going to be more oxygenated or it is going to be more weathered, which will reduce the tire's life. So then you head on to this label, interesting label you have, which the manufacturer has tested this tire under certain conditions and given you the parameters. So first you have the tire size, you have the tire's tread pattern name, and you have the manufacturer's name, and also you have the labeling here. So this label part says you about three important parameters which the tire has been tested for. So one is very important. This is the rolling resistance label. So now you know like there are label C tires, label A tire, B tire, so and so on till G, label G tires. So and then you have the wet grip index, which means when there is water on the road, how much efficient your tire will brake. So this will determine the braking distance of the tires on the um, wet weather conditions. And also, this is more towards the comfort. These two are more towards the handling and safety, and also the fuel efficiency, which is more important. And for customer oriented towards comfort or the noise levels, they also write the noise emitted by this single tire from the sidewall. So what if a user stands and there is a sidewall radiation of noise? This is also measured as per a specific condition, which we will deep dive into in today's video. But this is called as a pass by noise label. So for this tire, it seems to be a C label tire with the A class rating for wet grip index, which means it's very good for braking. So that makes it as a good tire for noise also. I will say why. So ideally, how this labeling works is with this magic triangle of tires. So you have a rolling resistance index. As I said, it's like a B, example C, etc. up to G. And you have noise labels. In our case, it was a C label tire with a 68 dB, oh, 68 dB noise, dBA actually awaiting, and also we have a wet grip index of A. So that is very good. So what it means from this is like it is a soft rubber which grips very good, and also it has very less noise emission because it's going to be soft. It's not going to hit the roads harder. So it's a soft compound that is on the tread cap layer. So that is the same reason why it is going to consume more fuel, because it's going to grip on the road more. Imagine you are rolling the tire, so it's going to uh, grip more to the road, and it's going to stick more to the road, which means you have to spend more fuel to overcome the resistance that is built by the rubber. So this is what we call as a magic triangle. If you build a tire focused on wet grip, then you lose rolling resistance. If you want a high rolling resistance, sorry, which means low rolling resistance tires which consume lesser fuel, then you have to lose a part of wet grip index and noise, which is going to be a harder compound. It's going to hit harder on the road, but it's like a steel running on the road. For an exaggerated analogy, I can say like a steel drum rolling on the road without any resistance. So that's going to be less costlier for fuel. So this is how you can understand this labeling, and you can buy as per your needs. This is very important for the customers who are buying tires. Now you can look into these labels. You can ask for these labels to the store in charge and say, hey, I wanted a comfortable tire. As in now we are seeing this Michelin Primacy 4. It's not any marketing, but it's like for example, I have taken this tire. It's like a coincidence or a random pick from the internet. I see this tire has a very good noise labeling and also very good grip index, but you lose a bit of fuel economy here. So it's based on the customer need. You can ask for the tires. So now you know how to pick the tire with the labels. So also like I've added a more detailed in-depth analysis of how this is achieved in my Udemy course. So I will pause to the next topic. So where I said about pass-by noise, so that is one of the index we have in the labeling. So this is the 68 dB. So how this 68 dB value is calculated? So this is more like from the noise standpoint. I will also create future videos on the other two parametrics, which is more important. Now in this video, I have clubbed the pass-by noise as it is a comfort-oriented thing. So how typically industries does is two ways how you can clear this test or you can get this homologated. One is outdoor track testing, another is indoor room testing, like anechoic chamber. That's what we call this chamber as, where you have sound absorbing materials on the side. So you can see these. These are called wedges, and these wedges absorb any sound in the ambient, and this is called anechoic chamber. And this is specifically is a semi-anechoic chamber, as you don't have any absorbing materials at the road surface or the platform. So it's like a semi-anechoic chamber, and you see here these are all the microphones that is going to measure the noise this vehicle is going to produce. So here you see a lot of microphones entire in this entire span, and here you can see a single microphone. You can see a microphone standing here, and also there is another microphone over here, so which will measure the both sides. As in here you also have the opposite sides. So typically how this measurement goes is you have a track. This is like an outdoor setup we have shown here, which is preferred because creating this indoor setup costs more. um, so like it is preferred to have this outdoor setup mostly. So industries go for this outdoor setup where your car passes through two lines called AA dash and BB dash, and the measurement happens at this point where the microphones are kept. So microphones are typically kept at a height of 1.2 meters, and they are spaced 7.5 meters apart. And your vehicle passes at 50 kmph and then leaves the BB dash line at 50 kmph. So this is called as a constant speed test. So this was added to the new regulation called ECE R5103. So this ECE is the regulation committee which says what your tire has to go through, how much like how it should be measured and how what is the cap value for this. So for example, 68 dBA was calculated as an average of this constant speed, and also there is an acceleration test where you enter this A dash line, which I said. So you enter here at a lesser speed and then you accelerate the vehicle based on the power mass ratio of the vehicle and which gear you have to select. Those will be in-depth analysis, but I will go on a surface level here. So you will accelerate and you will escape through the BB dash line. So this acceleration noise will be captured by the mic, and we take average of this constant speed noise and the acceleration noise to arrive at the final value, what we saw as 68 dBA in the example I have provided in the previous slide. But before this, there was only this acceleration passed by noise levels in the R5102 version, but after some changes to the regulation, the government body said, the regulatory body said, now we also have to add the constant speed noise. So that's why tires are now pronounced in their noise levels, because now going towards EV, there is no motors, there is no engine, sorry, and it is replaced with motors, electric motors, which makes it a bit dull in noise production, and tires started to roar higher. So that's why it's very important for tires to be more soundproof now. So industries are going through a lot to understand about noise generation mechanisms of tires. So that is of lot of types, and there is an in-depth discussion that will happen on my Udemy page. But for now, you can see there are two types of noise. One is airborne and another is structure-borne. So structure-borne is basically from road. The road will excite the tire, and the tread and the tire will excite what is called as a air pumping. So I will come into details of that. So now it will vibrate the tire, and there will be an air inside the tire which we fill 32 psi, 30 psi. That's what we fill inside the tire. This air will then vibrate the rim of the tire. Then it will vibrate spokes of the rim. Then it will go to the hub of the rim. Then it will go to the suspension. Then it goes to the body panel, and then it converts into a interior noise which we hear at the inside of the vehicle. So this is called as a transfer path. So from road to interior noise, there is completely structures that is taking up this vibration. And we also have airborne noise where it is going to be air radiation mostly. We don't have structures there. So there will be exterior noise. This is what we are measuring as pass-by noise in our example which we saw. And there will be like air pumping noise and noise from tire vibration. For example, the sidewall also vibrates like a drum surface, which will also seep into the passengers sitting inside through the windows, and we will hear it as a noise. So then there we have to speak about, of course, how this noise is being reduced by the industries. So, for general customer, you have to just know that your tread patterns, what you see on the tire surface, are not evenly dimensioned. So, what you see is called as a pitch sequencing, which industries follow to avoid any tread impact noise. Like you can take an example of a wheel having multiple spokes. Don't think this as a sun. It's like a drum with many welded plates. That's what you have to think now for my drawing. So if you roll this on the surface, you then hit, and if you measure this, there will be at a single frequency band, there will be a higher amplitude because you are hitting like tuck, 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 tuck. Then this will produce a noise at certain frequency. So what engineers have done here brilliantly is to make the width of the spokes different so that you reduce the amplitude and spread this noise towards like a broad band of frequency. So it will be like this will be of different width, this will be of different width. Imagine this is a bigger width, then you are going to create noise of different frequencies or different patterns, or what to say, like more of different sounds, so that you don't amplify the sound, rather than you scatter this sound to different frequency range so that the user don't hear it with a higher amplification. This is one of the strategy what the OEMs use to mitigate the noise, tire noise, and more like advanced things or to reduce the torus cavity noise. That is, the air inside the tire also vibrates and also it transfers, as you would have seen in our previous noise generation from tires mechanism. You would have seen the important thing, that is the acoustic cavity resonance. So this is what is solved by adding a foam layer inside the tire. Nowadays, the tire manufacturers are adding this foam to reduce the acoustic cavity resonance, that is the vibration carried by the air entrapped inside the tire. So like the tire is like this, and you have a rim that is closing this, that is being fitted into the tire. Then you have the air trapped here. So this air also vibrates. So that's why they have added a foam layer here, which reduces the amplitude of this noise. So these are the basic things which are like a corrective or a design measures that have been taken. But there are also in-depth analysis of design related parameters, how like how the shape of this tread or the shoulder should be, or how the belts inside the tire can be, the angles at which the belts are laid can also contribute to this noise, is like in-depth analysis. As I said, it's also covered in the Udemy page. So like this is the way in which the industry tackles the tire noise for now, and that's what you get after all this research and then development. You get the label of the tires as you see here for pass-by noise. So I will also add other videos of how the rolling resistance and wet grip index are measured and how the industries tackle, how the tire engineers work with these parameters also. But I hope this would have been an interesting surface level video and also will be useful to select your tires next time you head back to your garage. So thank you. And another insight, like closure is from me, is the Udemy course which I was speaking about. So I will add a link later to this channel where I will provide you the course structure and also what the course really talks about. And there, as I said, like whatever we have seen here as a surface level will be like more in-depth insights. So interested engineers or any professionals or even the customers can reach out there to know how the design and more aspects of construction, and also I was speaking about the compounding or the rubber of the tire, how they are chosen for different applications. And also like I will show you a glimpse of FEA, the finite element analysis tool, like the computer aided tool which is used in the tire development. So that also will be covered in the Udemy course. And also like how this tire design, as I said, like in the last part of the video, we also saw the foam tires, we also saw the pitch sequencing of the tread, but also I said about the roundness of the shoulder and the width of the tire, how these things affect the tire noise. So these small depth sessions will be handled by the Udemy part of the course. So I hope this YouTube video was informative and also not so elaborate to confuse the customers on uh, depth rather than cover all the surface level things, so as to make the user more informed before buying a good tire. Thank you. And as I said, I will also add videos on the other labeling aspects, but you can also check out the peak one, where I will speak in a depth for a customer to buy the tire, like what and all you should understand based on size and other parameters mentioned on the sidewall of the tire. So thank you for the patience, and thank you for the viewership.